Uh, we'll focus narrowly on the blood regulation of glucose, and that is the range that your blood normally operates at. So the range is between about 3.9 to on the lower side. On the higher side, it usually goes about 7.8 millimole per deciliter or per liter. So you can realize in Kenya, we usually use this unit of measurement of millimole per liter, but in many of the book references or in other countries, so the milligram per deciliter is rather preferred measurement of unit. But if you go to any hospital, that's the reference range for all the measurement in the laboratory parameters. It's usually quite easy to convert. So you only divide it by 18 and you convert the unit into millimole per liter. So shortly after you take a meal, the blood glucose will tend to rise between thereafter 3 hours, 2 to 3 hours, considering it takes about 3 hours for the process of digestion to be completed. And the blood glucose usually hardly goes below 2.7 for normal people. And anything below 2.7 will consider that one to be hypoglycemia. And anything above 7.8 will consider that one hyperglycemia and the condition associated with it. So as for today, we'll focus our attention between 2.7 on the lower side and 7.8 on the higher side. We have the two antagonistic hormone, as I said yesterday, that I told the class rep to give you a hint on what we'll study today. So the hyperglycemic hormone, these are the hormones that tend to shift glucose on the higher side, include glucagon being the major one. So we have other hormones that are not so much significantly increase the sugar, but nevertheless, they still do. One of them is the growth hormone that is required for the growth process. There's another hormone called ghrelin that we'll later talk about it while we talk about the digestive system. It's secreted by some part of the stomach. We have adrenaline together, which is secreted by the suprarenal gland. Tomorrow we'll talk about that one. We'll have T3 and T4, which are the thyroid hormone. We talk about it in our previous section, and we have also the glucocorticoids, what we call the cortisol or the steroid hormones, which we'll talk about them tomorrow. On the other side, we have the hormones that lowers the sugar to add the other side. We call them the hypoglycemic hormone, and the major one is usually insulin. So the response to hypoglycemia, that is when the sugars goes low, so must be very quick and effective, and it has to be terminated immediately because the effects are rather catastrophic. In that, when your sugar levels right now go too low, so they become too damaging as compared to when the sugar levels goes too high. So you will die easily in a shorter duration of time when your sugars level go below 2.7, but at sugars of 20, you can still be able to sustain them. And this is because of the damaging effect it has on the brain. But for normal individual, for you and I, in this session, we usually don't experience the extreme ends because of the two hormones that come into play. And that's just a point that says that usually the symptomatic hypoglycemia is usually can be seen in patients who are diabetic. So we have the sensors throughout our bodies, and these sensors work in place to ensure we have a fair play or a rather good mechanism that ensure we have a good regulation of the sugars. And I want just to take you back to our previous class where we talk about the two types of regulation. We have the negative control system and the positive control system. And I said that the negative system is utilized in all hormones except in oxytocin. In glucose regulation is still a negative control system. At the pancreas, we have the alpha cells and the beta cells. Those are our concerns in this class. So the beta cells are the ones that secrete insulin. So the beta cells contain a receptor, and this kind of receptors, we call it the GLUT2 or glucose transporter type 2, and is one of the receptors for glucose transportation. Another type will come into across it when you will see the absorption of glucose in the GIT. So glucose transporter type 2 is found in all the alpha cells receptor. And in your biochemistry class, you talk about the process of ATP production, that's the Krebs cycle, and the process of glycolysis. So the same process is utilized by these beta cells. So glucose enters these cells by production of ATP. So the ATP has some other channels, which are potassium channels. So the potassium channels in their cell membrane depolarizes, which upon depolarization, it will open the calcium channels. We know entirely also from our previous section that usually calcium tend to be an extracellular anion, of course, a cation in this case. So the depolarization of the potassium channels will cause the opening of the calcium channels. So once the calcium channels open, calcium will flow in down its concentration gradient. And once inside the cell, it causes the release of the previously synthesized insulin. And the level of the calcium inside the cell is regulated by expression of a certain gene. So this gene is called the element binding protein and is a gene that regulates the cell membrane receptor. So food intake and autonomic nervous system, as we later see another hormone called noradrenaline, has an effect in regulating the release of insulin. So the insulin release will stop when the glucose level comes to the normal level. So at this point, the alpha cells will begin to release glucagon and insulin will be reduced. So insulin is as strongly inhibited by adrenaline hormone. So it's just a still repetition of the same point that glucose from the blood will enter the special transporters in the cell membrane. So we say them the glucose transporter type 2. So these channels are sometimes indirectly under the regulation of insulin. And in some disorder, we'll later see that when we have a dysfunction in the regulation of insulin, we'll come up with two types of disorders. So that is type 1 and type 2 insulin diabetic. So activation of insulin receptors will lead into the cellular mechanism. And these are the processes that will later reduce the level of sugar in the blood. So one of the processes, and you still remember that we say the type of transporter involved is glucose transporter type 2. And these type 2 receptors are found within the beta cells receptors. So they act as our sensors for the amount of glucose available in the blood. So several cells are involved in the whole regulation, but the major one are the muscle cells. And at the muscle cells, insulin does the following. So it causes the insulin to be taken into the cells. So they have to be converted later from glucose into glycogen, which is a storage form of glucose. So another importance is the fat cells. At the fat cells, the sugar will be converted into fat for storage purposes. So these two cells usually are the major ones. So the muscle cells and the fat cells are where the sugar or where the body disposes excess amount of sugar. But since the body cannot store it in its form of glucose, so it will have to convert it into glycogen and dump it around 2-3 part of it. So the remaining one will have to be dealt in these other following ways. So as I said initially, we have the increase in the glycogen synthesis, and the process takes place in the liver. So once it has been converted, so the rest will be taken into the muscles. Another form or the process involved is the increase in fatty acid synthesis. So your body, as I said initially, that will consume or utilize the excess sugars to use in the normal metabolic processes, but the excess of it will have to be converted into the fat cells and deposited in your cells in the extreme part of the body. And of course, that is how you end up gaining weight or becoming fat, which nowadays that some can be considered as body shaming, but in physiology, we don't consider it that way. The process is by increasing the process of esterification, and these are the fatty acids simply converted into the fat globules and deposited. Another process is the degradation of proteins, called the process of proteolysis. So insulin inhibits that process and ensure that your body doesn't break down itself because you are made up of protein. We have the lipolysis, which is the conversions of fat back into the fatty acids, and the insulin will decrease that process, and the lack of it will cause the reverse. So the body usually, when it doesn't have enough glucose, there's a way it can make up glucose using non-glucose precursors. So these are the amino acids and the fatty acids. And the presence of glucose will decrease the production of glucose from non-glucose precursors. So this process is called gluconeogenesis, and insulin will inhibit this process. Another one is the uptake of amino acids. So immediately upon digestion and absorption of proteins, we'll end up with amino acids. So insulin will ensure that these amino acids will be taken up by the cells and deposited, and this one will increase the process of the gene expression. And then finally, we have the effect on the arterial wall forces. So this is not so much profound, but it will increase, it will relaxes the arterial and thus increasing the blood flow. But this effect is felt in rather micro arteries rather than the bigger arteries in the body. So that was enough about insulin, that it's secreted by the beta cells when the sugar levels is higher. So once the sugar levels start to go down, the production of insulin will immediately stop. And then the production of glucagon will be initiated by the alpha cells. So the secretion is initiated by either a low blood glucose concentration or an elevated amount of amino acids. So for example, immediately maybe upon starvation or eating, or when you go into exercise, when you start to exercise immediately, glucagon will be produced. And the inhibitor for that one will be the reverse. So in summary, the hyperglycemia, so insulin lowers the blood glucose level, and that one happens by dumping the excess glucose into the cells or converting it into a storage form, that is by converting it into glycogen, or sometimes just breaking it down. So, but then glucagon stimulate on the other side, so it causes the reverse of everything that insulin does. So these are all the reverses that we talk about. So as for example, glycogen will cause the breakdown of the glucagon causes down the break of glycogen and convert it back into glucose. So we call that one the process of glycogenolysis. And then it will also initiate the mobilization of fats. So it will cause the breakdown of fats and later convert it into glucose. And the aim is to bring back the normal sugar concentration level into the normal ranges. So some of the medical uses of insulin is to be used in type 1 diabetes. So it's called insulin-dependent type diabetes, or simply type 1. So this tend to happen in childhood because of the damages of the beta cells, and the person has to depend entirely on exogenous or external source of insulin for their life. Equally, we have type 2 diabetes, which tend to be common in adult and is associated with obesity. It's caused by the desensitization of the glucose type 2 receptors in the extremities, in that you become insensitive to glucose and you have to depend on some other drug that either sensitize it or drugs that will lower glucose level, and this one tend to happen in adulthood, so it causes type 2 diabetes. So those are types of diabetes. But while doing pathology, you realize we later have type 3 and type 4. So type 4, we call it a gestational dependent, which tend to happen in pregnancy, and type 3 is another type of diabetes. So those are beyond the scope of this class of the normal physiology. The pathology class will talk in details about them. So still just a quick recap on what we have covered this morning. So the normal blood glucose level is between 2.7 and 7.8. And anything below 2.7, we consider that one to be hypoglycemia. And anything above 7.8, we call that one hyperglycemia. When the sugar levels goes high, insulin is secreted, and it causes the dumping of excess glucose into the cells. So the major one are the fat cells and the muscle cells, but also a small part of it will be stored in the liver. So it will inhibit all other processes. And once the sugar levels start going down, the production of insulin will immediately stop and glucagon production by the alpha cells will be initiated. Glucagon will cause a reverse effect of what insulin has been doing. And the purpose is to mobilize glucose from the storage and later dump it in the blood level. And that is a summary regarding the precise regulation of glucose metabolism.